Hello guys, am I visible? Good morning, good morning. Good morning everyone. फिक्स करते हैं थोड़ा लाइटिंग का इशू आ रहा है क्या? सर चेक करिए तो अरे क्या ओनली 34? आ जाओ बाकी सब आ जाओ. गुड मॉर्निंग guys. Board is visible, right? So come in everyone. So live chat देख लेते हैं, all live chats. Okay, 720p low quality. Sir, rotate your mobile. Is mobile not good? Tilt your screen. क्या बोल रहे हो बेटा? Okay. ऐसे पढ़ोगे क्या? नहीं, ऐसे थोड़ी ना पढ़ा जाता है. Is it okay now? Auto rotate is on, right? So good morning everyone. So today we will start our upcoming topic, which is hydrolysis of a salt of strong base and a weak base acid, right? Yesterday we completed salt hydrolysis. Let's revise what we have completed yesterday. No sir. Are is it okay? Is it okay? Correct. Viewing is correct today. No reflection, right? No reflection, viewing is correct, right? Yes. So yesterday we have completed the salt hydrolysis of first one, which was weak base plus a strong acid, right? So weak base NH4OH and a strong acid HCl, correct? Yesterday we have completed this. So what was happening there? Now this NH4 plus from the weak component was going under hydrolysis. So screen reverse. Okay. Yeah, that's what I was saying previously. So screen reverse कर देते हैं आप लोगों के लिए. Change the screen ratio into landscape. Hello sir, is it not good?
It is okay.
सही तो है, और क्या चलेगा?
Why you rotate the screen?
अभी देखो.
Don't rotate the screen. The screen is good. Okay, now you can go live. It is okay.
90 degree. Array, no 90 degree rotation. You can see now, right? Sir, body. So now I think it's correct. Right? Array, beta, we have tried everything. Better you can take classes by June. Okay. So yesterday we have completed the hydrolysis of strong acid as well as weak base. Array beta, look, just open your YouTube and take it into array. Just increase your quality into 720p. Just increase your quality into 720p. So yesterday we have completed the hydrolysis of a weak base with a strong acid. What was the salt? NH4Cl was the salt. How it was dissociating? NH4 plus Cl minus, and this NH4 plus was undergoing hydrolysis to give again NH4OH, reversible arrow always here, plus H plus. Okay, NH4OH plus H plus. So what was the pH formula? 7 plus half pKb minus half log C, right? How was it? Seven minus half pKb. So we have taken this common. We have taken out this minus common. So 7 minus half pKb plus log C. So can you clearly say that this is a weak base and this is a strong acid? So the solution is acidic, right? Acidic solution. So as it is an acidic solution, pH should be always less than 7, and we got in our final result that pH is always less than 7 for this acidic solution, right? Now everybody able to see? Everybody able to see the board correctly? Everybody got it? Everybody got it? What happening, Vignesh, just take your YouTube video into full mode. Okay. What is happening? What is the problem? Can anybody write? What will be the problem? Rotate the mobile. Okay. Okay, let's rotate it once. Now is it okay? Yes. Hopefully. Yes. Hopefully now it is okay. Hello. Yeah, yesterday only. It's kept. Hello. Yeah, yesterday only. It's kept like yesterday only. Yes. Keeps. Okay. Yes, it's like yesterday. Mobile is like yesterday only, beta. Is it correct? Is the view correct or not? What is the problem again? No sight. Better students enable rotate. Students enable rotate lock option. Yes. Array, you are not opening your YouTube in full screen? Keep your mobile in vertical. No beta. Vertical, no classes in vertical mode. Always we have to take classes in landscape mode. So please rotate your mobile. Please rotate your mobile whichever way you are comfortable to see. And you are all adults, right? You are all better than technology. You are all better in technology than me, right? So there is a not. So this was the previous class revision where we got pH is equal to half pKb. 7 minus half pKb plus log C, right? Then today is our task to calculate pH of a salt which is made up of strong base plus weak acid, right? Do you know any strong base? NaOH, right? Do you guys know any weak acid? Batao. weak acid. अरे एसिटिक एसिड छोड़ के हमेशा जिंदगी भर एसिटिक एसिड लेते रहेंगे क्या? HCOOH, formic acid. Okay, so no Rakesh, not acetic acid, formic acid ले लो इस बार. So we will take formic acid this time as a weak acid and NaOH as a strong base. So COOH, formic acid is also an organic acid, right? Plus NaOH, and all of you know what will happen. Acid base neutralization, right? It will give us salt and water. What will be the salt? Can anybody suggest me what will be the salt? Can anybody suggest me what will be the salt? Oxalic acid? Yes, oxalic acid we can take. What will be the salt? Salt will be basic. I know. What is the formula of that salt? CH3CONA, which is a basic salt. Correct. Which is a basic salt, and it will give us water also. Correct, Rakesh. Correct. Everyone who is answering. So you know this, right? Then what will happen? This salt again can go hydrolysis, right? This salt can again go hydrolysis. Yesterday we understood what is hydrolysis. Hydrolysis means addition of water into the salt. Okay, so what will happen? If again it goes under hydrolysis, this will again reproduce both the components. It will again reproduce both the components. Look, OH minus will react with the NaOH, and H plus will react with the acid, right? So our final solution will be again a basic solution. But why this is in equilibrium? Look, there will be two parts, minus plus Na plus. So yesterday we discussed hydrolysis will be always for weak part. Why not for strong part? Hydrolysis will be always for weak part. Why not for strong part? Let's discuss. Okay, I am erasing the top part. So whenever you want to, you can pause the video and keep it a note, or you can take a screenshot. So we are pausing this. Then why not the strong part? Look, if Na plus is hydrolyzed, let's discuss. If Na plus is hydrolyzed, what will happen? Na plus will take up OH minus from water. Yes or no? Then what will it form? A very strong electrolyte, NaOH. So if I put a reversible sign, is it correct? No, right? This reaction must be going 100% or 99% in forward direction. Right, 99%, and 1% will be coming back again to dissociate. Or if we think otherwise, that NaOH is dissociating, that means 99% of dissociation will happen, and at max 1% will be remaining, right? Because this is a strong electrolyte. So will there be any equilibrium? If we have a strong electrolyte, will there be any equilibrium? Can any of you answer? If we have a strong electrolyte, will there be any equilibrium? No, right? So strong electrolyte will not undergo hydrolysis. Only a weak part of our salt will go hydrolysis. Okay. So please note it down or take a screenshot. Then we will go to the next part, how to calculate the pH in this part where we are making a salt from a weak acid and strong base. Yesterday we discussed about strong acid and weak base, right? Today we are discussing about a weak acid and a strong base. So take a screenshot. Pause and take a screenshot. Go back, pause and take a screenshot. Or if you are writing, take a screenshot and write afterwards. Then Then we have our hydrolysis component. So can we now write equilibrium or equation of hydrolysis? Equation of hydrolysis. So now only we discussed that only weak component will undergo hydrolysis. And in our salt HCOONA, weak component was HCOONA, weak component was HCOO minus, right? Na plus was our strong component, HCOO minus. So it will take H plus from water, right? Or I can directly write addition of water. It will give us, what will it give us? Can I put the reversible sign? Yes sir, because it is a weak electrolyte, so it will dissociate very less, or if it is forming also it will. Correct, right? We'll get the weak acid plus OH minus. And for this equilibrium, for this equation of hydrolysis, for this equilibrium, what we are writing? Yesterday we wrote KH. What will be the KH? Product by reactant, right? Equilibrium constant for this reaction. Product by reactant. What will be it? So what is our products? Acid OH minus divided by HCOO minus. Correct? We got the KH. And there was two other equilibrium going in the system also. There was two simultaneous equilibrium. Again, after forming this weak acid HCOOH is formed, and this will also again dissociate back, right? We know it is a weak electrolyte, but it will dissociate, right? At least 5%, 6%, 10%. So HCOO minus plus H plus. And what will you write here? Ka, right? Acid constant. Can you write the acid constant here? Can anybody write the acid constant here? And what is the third thing going in the system? What is the third thing going in the system? Can anybody say? How many equilibriums? So in hydrolysis, we have three equilibrium reactions undergoing simultaneously. Three equilibriums. So first one is hydrolysis of the weak part of the salt. Again, the weak part which is forming weak acid or weak base, that is also dissociating. Again, third component, which is this? This is our favorite water. So water will also dissociate, na? Water will dissociate as H plus and OH minus. Can you write equilibrium constant for dissociation of water? What was that? KW, right? KW was H plus into OH minus, and we will not consider the concentration of water. And why we will not consider? We have discussed it 1000 times, and now also I am telling why we are not considering water, because water is in excess amount and it will not affect the concentration that much, right? Okay, then what will be on this side? CO minus H plus divided by HCOO H, right? So can you write a Ka, acid constant expression, which is products divided by reactant, right? Concentration of products divided by reactant. So we got this. So we have three equilibriums in this medium. Then what will you do? We have to find a way to calculate a relation between KH. We have to find a relation between KH, Ka and Kw. Like yesterday we found relation between KH, Kb and Kw, right? What no? Okay. Manda Sri Krishna. Okay, you are understanding, right? So we got three equilibriums. Then we have to find the relation. Please take a screenshot of these three equilibriums. Then we will go to find a relation now. Guys, please take a screenshot. Okay. So only 64. Please go back, pause and take a screenshot. Only 64 today. Why? Our strength is around 200 or 300. Why you are only 64? Others are enjoying the holiday? Okay. So let's see. We have three equilibrium. Now we have to calculate a relation between. Beta, once again, Array, here no once again. Just go back. Just go back in the live video. Beta, what is the name? Manasa. Manasa, just go back in the live video and you can see once again. There is no need for me to repeat again. Okay. You can scroll back in the live video, right? So, relation between KH, K and KW. So, now again we have to make the parent equation. We have to make the parent equation from the two other equations. So, what was our parent equilibrium? Can we write HCOO minus plus water is giving us LCOOH, which is our weak acid, plus H2O. And what was our other two equation? Water was dissociating into H plus and OH minus, where equilibrium constant was Kw, and HCO formic acid was dissociating us CO minus plus H plus. What was the acid constant? K. Here the equilibrium constant is KH. What is KH, beta? What is KH? Can anybody say? So I need to get this parent equation from these two top equation, and you know how to do this, right? You know how to do this. So first of all, I need this in reactant side. But this is in product side, right? Could you explain in a better and enjoyable? Array? इंपॉर्टेंट टॉपिक है बेटा, इधर एंजॉय करने का कोई चांस नहीं है. इंपॉर्टेंट टॉपिक है, पढ़ो. जेई में कोई आपको एंजॉय नहीं करवाएगा, उधर डिफिकल्ट क्वेश्चन आएंगे. Okay, so listen. So we have KH, KA and KW. We have to calculate a relation between them. Yes, Srivastav Arya, you are very good. You remember that it is KH, and which is our hydrolysis constant for this hydrolysis equation. Okay, so can we calculate relation? This is on the product side, so I can reverse this, right? Reverse this reaction. So what will happen to the equilibrium constant here? It will become 1 by Ka. So look, when we reverse, can we cancel out this H plus and H plus? Yes, because that is on the reactant side, that is on the product side, we can cancel. And what is remaining? This HCO minus and water, right? Both of them are remaining. And then we have formic acid in the product side. So while reversing this equation, this is going into product side, correct? Can we add these two now? Can we add these two equations to get the final equation? So take a screenshot. So this is not done anything, so Kw will be Kw. This equation will be reversed, so Ka will be 1 by Ka, and we got our final equation of KH by adding the Kw plus 1 by Ka. So when we are adding two reactions, equilibrium constants get multiplied. You know it from our basic classes from chemical equilibrium, right? Take a screenshot and we will use this conclusion. So what was our conclusion? Now KH is equal to Kw into 1 by K. Make it a box. How we got this? So derivation is not important from our JEE mains perspective, but in JEE advanced you may get stuck in some of these steps because you will get MSQs, right? So please, who is aiming for advanced, please look at the derivations very seriously, and who is only aiming for mains, please go with the formulas. Okay, I am giving you the end formulas and also doing some problems for you, right? So take a screenshot. Nice, today's strength is more, 68, 69 students today, so take a screenshot. Okay, so remember this result, KH is equal to KW into K. So again we will play with the equilibrium equation, again we will play with the hydrolysis equilibrium equation. And let's see what is happening.
Okay.
So how hydrolysis was going on? CO minus plus water it was giving us HCOOH plus OH minus. So you can see we are releasing OH minus, means this solution is basic. This solution is basic, and we have to calculate POH first. We have to calculate POH first because we are getting OH minus in the equation, not pH plus. So if we are getting H plus, we will calculate pH. If we are getting OH minus from our equation, we will first calculate POH and then right, 14 minus H plus. So let's check at time t is equal to 0. So this is excess, just forget about it. Let's see, this is at C amount, right? This will be 0, this will be 0. At time t is equal to T equilibrium, this will be C minus C alpha, right? This will be C alpha, this will be C alpha. Alpha is a dissociation constant for 1 mole. If you are taking C moles, then it will be C alpha, right? Then this alpha is also can be written as H, which is degree of hydrolysis. What is the formula for degree of hydrolysis? Number of moles of salt hydrolyzed divided by total number of moles of the salt. So how much is hydrolyzed? It's same like dissociation constant, very similar to alpha, but we are using small h here. And you can use alpha. Don't confuse yourself with lot of constants, lot of variables. So you can use alpha. It's same thing only. But when the hydrolysis is happening, the alpha from the name of alpha from degree of dissociation, it is changed to degree of hydrolysis. Very same concept, just number of moles of salt hydrolyzed divided by total number of moles of salt we have taken, which is C, right? C amount of moles of salt we have taken in 1 liter. If volume is changed, again you can vary the moles, right? You know all those. So let's come to our main business end. What is the concentration of this? OH minus. We need OH minus concentration to calculate POH, right? That is C alpha. And from Ostwald's law of dilution, Ostwald's law, what do we know? Alpha is equal to root over of Ka by C or Kb by C. We know this, right? Then, can I write OH minus concentration is equal to C alpha, which is equal to C into alpha के place में we can put Ka by C, right? We can put it, right? Then what is the equilibrium constant here? It is Kh. So can we put Kh, and we have the relation of Kh with Kw and K, right? H is equal to Kw and K for this equation where we got in the previous slide. So H minus will be equal to Kh into C, right? So can I put Kw by K into C? Then can you take negative logarithm on both sides? Minus log OH minus, it will give us half, log of minus log of Kw by Ka into C whole to the power 1 by 2, and that 1 by 2 will come out, right? That 1 by 2 will come out here. So it will be POH is equal to half minus half log Kw into C by Ka. Can you solve this part? I am asking to all of you, can you solve this part and tell me what is the result? Take a minute, take the screenshot and solve. Pause the video, take a screenshot and solve this final equation. We are getting POH is equal to minus half log Kw into C divided by K. So please try to solve that. Then we will go to the next part. Hopefully all of you have taken the screenshot. Otherwise you can go back and take the screenshot again. So I am keeping the final result from where we will calculate our final pOH formula. Then we will convert it into pH. So pOH is equal to minus half is outside. Then log Kw will be there plus log C will be there, and if K is in denominator, so what will happen? Minus log Ka. So three things. Then if you multiply half inside, it will be minus half log Kw minus half log C plus half log K. Right? Can I write this minus half log Kw as pKw? Can I write plus half pKa log Ka as minus half Ka, and I can write this as half log C, right? So pOH will be equal to all of this. And do you know what is the value of pKw at room temperature? Do you know what is the value of pKw at room temperature? 14, right? So half into 14 minus half. Can I take minus half common? pK plus log C, right? pOH we got half into 14. Half into 14 minus half pK plus log C, right? Got it? So then what will be final pOH will be 7 minus half into pKa plus log C for a salt of weak acid and strong base. Then we got the pOH. We know this is a basic salt. We got the pOH. Can you calculate pH at room temperature? Because we are taking room temperature only at 25 degree centigrade. So can you calculate pH from here? What will be pH? pH will be 14 minus S, right? 14 minus pOH, right? So let's take a screenshot again. Let's take a screenshot again and move to the next part. Is the board is very small for you guys? You can take screenshot and write down, right? You have whole day. Okay. So I will be keeping the last lines whenever I am erasing the board for the next time. So then we will do a very simple question after calculating the pH. So we know pH will be 14 minus pOH. So just put the pOH value 14 minus 7 plus half into pKa plus log C, right? Correct or wrong? And I just put it this pOH value, take it as an equation 3 or 4, whatever it is continuing, and put it here. So this will be 7. 14 minus 7 will be 7, right? 7 plus half pKa plus log C, right? Half pKa plus log C, pH, for salt hydrolysis of a weak acid with strong base. Right, weak acid was formic acid and strong base was NaOH. So can you write down this? Can you take a screenshot of this? Hopefully board is clear. Can you take a screenshot? Okay. Still 61 people watching. Going back again is also don't know. Going total brainless. Going back again is also don't know. Alright. Going back on YouTube, you can go back, right? Take a screenshot. So let's discuss a very good question. calculate the pH of salt okay, and concentration is given 10 to the power minus 2 molar. Salt concentration is given 10 to the power minus 2 molar. What is the salt? Barium lactate. So it is a salt of BaOH base, BaOH hold to strong base, and lactic acid, right? Lactic acid is a weak acid. So this is salt of lactic acid and barium. Is this will come on YouTube? Yes. After the class, it will come on YouTube live. YouTube uploaded videos. You can check. Yesterday's class is also there. And then let's see Ka value for lactic acid is given. What is that? 10 to the power minus 5. And you know Kw, right? Kw is always 10 to the power minus 14 when 25 degree. If the temperature is mentioned 90 degree or anything else, you can change the Kw, you can change the formula. So what will be the pH? Now only we discuss. This is a salt of strong base and weak acid. So today's formula we can use 7 plus half. pH will be 7 plus half pKa plus log C. So we know what is pKa. If Ka is 10 to the power minus 5, pKa will be plus 5, right? So 7 plus half into plus 5 plus, can you tell what I can put in the place of C? Can you tell what I can put in the place of C? So I have to put the concentration of initial concentration of the salt, right? Can you tell? Anybody? Basically advanced aspiring students. Can you tell what will you put in place of C? 10 to the power minus 2 molar is given, the concentration of the salt. Can you say what will you put in place of the... Yes, hello, Sasank. Can you tell what will you put in the place of C? Nobody can tell. So look, this salt, barium lactate, will dissociate as salt is a strong electrolyte, so it will dissociate barium 2 plus and 2 of lactic acid minus, right? So if this is 10 to the power minus 2, this will be 10 to the power minus 2 and this will be 2 into 10 to the power minus 2, right? 2 into 10 to the power minus 2. So I always told that you have to put n factor or you have to multiply n factor always. Yes, very good. PG squad and Srija, very good answer. So I can put log 2 into 10 to the power minus 2. Correct or wrong? So pH will be 7 plus half into 5 plus log 2 plus, and I know right, log A into B. So I can write log A plus log B, 10 to the power minus 2. And this minus 2 will come out. Okay, this minus 2 will come out and log 10 is 1. So can I calculate? Can I calculate in this one line? 7 plus half into 5 minus 2. What is the value of log 2? 0.3, right? So 3.3 into half. 3.3 into half, right? 3.3 into half क्या होगा? 1.65. So 7 plus 1.65 will be 8.65, and we know pH 8.65 is basic pH. So it is always evident we are using a strong base and a weak acid, so solution will be basic. So please take a screenshot of this problem. This type of problems are very common in mains as well as NEET. Like if you go back before 2017, 2018, there was no questions on this thing. But now every year we are getting questions from salt hydrolysis, especially mains. And in advanced we are getting mix-ups between buffer, salt hydrolysis, weak acid, weak base, and strong acid, strong base. So all the pH questions are mixed up in the case of buffer. Okay. So please take a screenshot. Then we'll move to a very interesting part today. We'll play with the acid-base titration. Okay, we'll play with the acid-base titration. Can I clear? Can I clear this? Yes. So you can go back and take a screenshot if you have not taken it yet. Hopefully this problem was understandable to all of you. Where we got the acidic pH, basic pH of 8.7, 8.65. Then let's go to the next part of this video. Today we'll understand. Okay, one more thing is left, right? One more thing is left, which is weak acid plus weak base. What will happen when a weak acid will react with weak base? Sir, same thing, sir, salt, but water will come. Will water come? Yes, sir, water will also come. So let's see what is happening. Then we'll go to the pH curves. Okay. So let's see. I can again take the weak acid as HCOH and weak base as NH4OH. NH4OH, ammonium hydroxide, is our weak base and formic acid is our weak acid, right? What someone written? Suneet Patel. Once again explain. Beta, this is YouTube. You can go back and once again you can see thousands of times. So I don't need to explain once again. You can go back and see. Okay. You can go back in the video and see whatever you want. So what will happen? This salt hydrolysis will happen. These two salts will react. So we'll get COONH4 plus water, right? This will be our salt of weak acid plus weak base. So we know hydrolysis will happen only to the weak part. But sir, here both of them are weak part, right? Here both of them are weak part. If I add water, what will happen? It will hydrolyze. It will hydrolyze. Both of them are weak part. So it will hydrolyze to form HCOOH plus NH4OH. Again back. So this two ions from this salt, HCO minus. This is also weak and this is also weak. So both of them will undergo hydrolysis. And the equation of hydrolysis will be this. Equation of hydrolysis will be this, right? We are getting NH4OH. So COO minus and NH4 plus both reacting with water and giving us two weak acid plus weak base. So can you write KH for equation? KH for this equation? Yes sir, we can write product by reactant, right? Always product by reactant. KH will be product by reactant. HCOO NH4 into, shall I put water? No sir, water will not be there. So this is our KH value. Right? So here and others, Rakesh and other, they are not responding anymore. Are they sleeping? So hopefully take a screenshot. And then we'll discuss what are the other equilibriums existing in this system. So here how many equilibriums will exist? Can anybody use their brain? Chota sa jo brain aapke paas hai, can anybody use? And say me how many equilibrium exist in this system? So how many species who can make equilibrium here? So first equilibrium we got here, right? Equation of hydrolysis, this is the first equilibrium. How many other equilibriums can exist in this system? How many other equilibriums can exist in this system, beta? Anybody in the comments? How many other equilibriums can exist? Other three. Yes, Rakesh, very good. Other three equilibrium. Another one is due to weak acid. Next one is due to this weak base. Other three. Bhavani, other three equilibriums. Rakesh is right. So we will get due to this weak acid. Another one is due to weak base. And another one, final one is due to our water, right? So except salt hydrolysis, we will get 3 more equilibriums. Hopefully everyone understanding. So let's write down one by one. What are the equilibriums and what will be their equilibrium constants? Okay, so I can write here. We'll get a Ka for this weak acid. Weak acid के लिए अपन को मिलेगा acid constant Ka. We'll get a Kb for this base, weak base. We'll get a Kb for this weak base, right? And we'll get a Kw for this water. Water के लिए we'll get Kw. We'll get a Ka for this. We'll get a Kb for this weak base, and we got a Kh for this complete hydrolysis equation. So now what relation we need to calculate? So we need a relation between KH, KB, Ka and Kw. Oh sir, चार variable, four variables. We will take a relation between them. So let's see. So our parent equation will be this one. We need this one from these three. So how will you make? So let's see how will you make. Due to less conjunction, I will write little equations. So please cooperate. So you remember the parent equation, right? Salt plus water giving us weak acid and weak base. So salt is hydrolyzed to give us again weak acid and weak base. This is our parent equation. So hopefully go back and pause and take a screenshot. Then we will proceed. So let me write the parent equation below, or I can write all three above and then go to the parent equation. So first is water. Always we are keeping water first. Some people keep it last. So it's up to you, right? So it will be Kw. Correct? For water it will be Kw. Then for formic acid, it will be Ka. For this weak base NH4OH, it will be Kb, right? And what is our parent equation? This salt. HCOO minus plus H4 plus NH4 plus. So this is our salt, right? Plus water is in equilibrium with weak acid COOH and with. So here equilibrium constant is KH. So you can directly see, right? You can directly see. I need these two in product side. Weak acid and weak base. But they are in reactant side. So what will you do? What will you do to the reaction? Just reverse them to get into product side, right? You are not getting. So you will just reverse them. First reverse these two reactions. So Ka will become 1 by Ka and Kb will become 1 by Kb. And water is in this place. Then what will cancel out? This H plus will cancel out this H plus, and this OH minus will cancel out this OH minus. So what will be the final relation if you add these three reactions? So Kw divided by Ka into Kb. Right? Equilibrium constants are multiplied whenever you add more than two equilibriums. Got it or not? So Kh will be Kw by Ka into Kb. So can we jump into the pH formula now? Let's see for due to what we are getting pH here. Here we have both OH minus and H plus. So what we are getting, let's see. Sorry, 1 second. Just take a screenshot. I'm erasing. So hopefully if we complete this by today, we'll calculate the pH curves tomorrow. pH curves are also very interesting things. It's all based on the salt hydrolysis, buffer, weak acid, weak base, strong acid, strong base. So everything will be revised. So I am planning to do that offline. So everything will be revised in pH curve topic when we are doing a pH curve, we will revise everything. Like strong acid का pH का formula, weak acid का pH का formula, mixture of strong acid, weak acid, mixture of weak acid, weak acid, mixture of strong acid, strong base, strong acid, weak base, weak acid. Then we have to go to buffer. Then we have to go to hydrolysis. So it will be a very good fun exercise. So one class will take the pH curves, and it will be very good fun exercise for all of you. Right? So where are we? We got the final conclusion of this equilibrium: COO minus plus NH4 plus water is converted into NH4OH plus formic acid HCOOH, right? Is it correct? So what will happen? Let's see. The initial concentration of this is C. This is C. This is C. We don't need to consider this. This is 0. This is 0. So at time t is equal to 0. Then at time t is equal to equilibrium. After hydrolysis, what will be this? C minus C alpha. C minus C alpha. Right? Then we'll have C alpha and C alpha. Right? Is blue pen correctly visible? Or you are more comfortable with black? Is blue pen correctly visible? Please, anyone? Is any problem in the visibility, viewing, board, or I am doing any problem? Please don't tell that online class is the problem. So we got the KH relation. So can you write KH from here? KH will be product C alpha divided by reactant. C common लेंगे तो 1 minus alpha, C common लेंगे तो C square 1 minus alpha, right? So all C square and C will be cancelled. So alpha square divided by 1 minus alpha का whole square. Again alpha is very less than 1. Alpha is very less than 1 for weak electrolytes. Alpha is very less than 1 for weak electrolytes. So KH will be, can I ignore this? 1 minus alpha. Can I make it 1? Because alpha is very less than 1. So 1 minus alpha will nothing differ much with the color. Okay, very good, Rakesh, thank you. So color is not matter here. So alpha will be root over of KH for this special type of equation. Here Ostwald's law is also not valid. Okay, Ostwald's law was for single weak electrolyte. Here we are having two weak electrolytes, so alpha is equal to KH, only root over of KH. Everybody understood? Everybody understood why we ignore and how we got alpha is equal to KH? So what will be C alpha? What will be C alpha then? C into root over of KH. So we know the KH value. Can we do? We know the KH value. Can you put the KH value? What was the KH value? KW by KA into KB, right? By KA into KB. Can you put it here in this equation? And tell me what you are getting. So we again know, we have to know where the H plus is coming, right? H plus will be coming from this weak acid. So if we can calculate the pH, if by any way I can calculate the amount of H plus and I can calculate the pH, then I know what is the pOH. So there is no difference. So please take a screenshot and I will erase some part. So I will keep the final relation only. then we need some space to do other things. So these are the final relations we are having. Then what else? So I need H plus, but there is no direct H plus ion. There is no direct H plus ion in the system. I need H plus, but there is no direct H plus ion. So what can we do? H plus ion will be Ka. So please remember what was the Ka for acid. Please remember what was the Ka for a acid. So it was HCOO minus. For formic acid, Ka was HCOO minus plus H plus divided by acid, right? Product by reactant. So what will be the H plus amount from there? Ka into HCOOH divided by HCOO minus, right? So this is the H plus ion concentration we are getting, right? Can we put these two concentration here? This is C minus C alpha, this is C alpha, right? C minus C alpha, this is only C alpha. I put wrong. So this is C alpha, acid, and this is C minus C alpha. So can I cancel this out? 1 minus alpha, right? Then if H plus is Ka into alpha by 1 minus alpha, as again we know alpha is very less than 1. Can I ignore this? So H plus is coming Ka into alpha. What is the alpha value? Ka into root Kw. So we got the H plus ion concentration as Ka into root over of Kh. Right, Ka into root over of Kh. So take a screenshot. This is a very long derivation rather than others. So can I put Kh value here? Kh value is Kw by Ka into Kv. So H plus ion concentration is Ka into root over of Kw by Ka into Kb. So if this Ka goes inside, what will happen? Ka square, right? If this Ka goes inside, what will happen? H plus ion concentration will be root over of Kw into Ka square divided by Ka into Kb. So 1 Ka cancel, right? So H plus ion will be root over of Kw into Ka divided by Kb. Correct. So this is something different from other two. So this is the most important case we are discussing in weak acid weak base case. So from here we can take it equation 3 or 4, whatever is going in this derivation. Then can I take minus log on both sides? Can I take negative logarithm on both sides to make it into pH? So minus log H plus ion. Concentration, never forget to put the concentration bars, will be minus log Kw into Ka divided by Kb whole to the power 1 by 2. So pH will be equal to half log Kw minus half log Ka minus half log Kb, right? So Kb will be minus and this minus is outside, minus plus half log Kb. So can I write the final thing? So let us take a screenshot and then I will write the final formula for this mixture of weak acid and weak base. So take a screenshot, dear all. Please pause the video, go back, pause the video and take a screenshot if you have not taken it. So what is the final thing? We are getting pH is equal to minus half log Kw. Then we are getting minus half log K and we are getting plus half log Kb. And you know minus log Kw, pKw. So half pKw minus log K, half K, right? Then plus log KB. So can I make it plus log KB? Can I make it minus half log KB? And can I make it as minus of half PKB? Yes sir, I can make. So can I put this value, which is 14 plus half? Can I take half common? PKA minus PKB. Okay. So pH will be this much. 7 plus half pKa minus pKb. Why both pKa and pKb comes in our final formula? Because this is a mixture of weak acid and weak base. So pK is for weak acid and pKb for weak base. So write down the final formula. This is very important. This is very important. Weak acid, weak base case. Very important. Okay. And I will do a very simple problem on this concept and we'll end today's class. What is the time? I think your patience is breaking. Only 47. Okay, good. Whoever wants to study can still stay till the end. Whoever don't want to listen, you are enjoying your family time, I can understand. Okay, so if you are enjoying your family time, we will not disturb you. Please write down up to this. Take a screenshot. Then we will use this formula in a very good problem. So write down the question. There is a mixture of weak acid, which is 0.2 molar, HCOOH plus weak base 0.3 molar NH4OH, right? Here pKa is given 5 and pKb is given 4.8. Okay, so directly I am giving you pKa and pKb. So can you calculate when this is a mixture of salt acid, strong acid, weak acid and weak base. So there is no role of initial concentration C in pH calculation. So there is no role of initial concentration C in the pH calculation. So can you directly put pH is equal to 7 plus half, pKa is 5 minus 4.8. So 7 plus half 0.2, then 7.1. Is it basic? Yes sir, it is basic. So it depends upon the relative strength. Whenever I told in class that the mixture of weak acid and weak base, you will decide the salt is basic or acidic or neutral. Depends upon the relative pKb or pKa value or the relative strength. You can understand from this formula right now, right? In the salt hydrolysis part. So always you are adding water. Without water, salt hydrolysis is not possible. As in the previous class we discussed, what is hydrolysis? Means addition of water. So take a screenshot of this very good basic problem and you will find a lot of tough problems in your module and we will discuss physically. All of them we will discuss physically. Okay. So please take a screenshot of this. Thank you. Hopefully you enjoyed both the online classes where we discussed the salt hydrolysis pH formulas for weak acid, weak base, then for weak acid, strong base, strong acid, weak base. And we know strong acid or strong base, strong acid will not have this hydrolysis because strong electrolytes doesn't undergo hydrolysis. Now only we discussed like Na plus or Cl minus, whichever the strong acid, strong base electrolytes will not undergo hydrolysis. So these three cases and the fourth cases is not. Okay sir, do you repeat this class? अरे रिपीट कर दो ना, तुम्हारे पास YouTube वीडियो है, रिपीट कर दो. सिद्धार्थ रेड्डी, do you repeat this class in college again? So that is a very good question. I don't know if lot of students wants to repeat, will repeat, Otherwise, we'll just discuss the formulas and we'll go to the problem part, right? We'll go to our mains and advanced part. So it's up to you, it's up to your batch. If maximum students not able to attend online classes, I know some of you are in from village area and there is no internet. So we understand that also. If lot of your batch mates will want that we'll repeat all this, then we'll repeat in the class. Okay, if you don't want to repeat, you can directly proceed to the problem. You know all the formulas, so you can directly proceed into problem. We'll discuss them in the class. So it's up to us. So what will be our next task? pH curves. pH curves, indicators and titration. So all of these things we will discuss tomorrow. So please take a leave for today. Thank you for joining. So if you have any other questions, any other doubts, you can ask in the live chat box now. When will be the class end? Beta, class is already ended. If you want to ask anything, if you have any small doubt, anything in the today's class, or if you have any request, we'll discuss. Class is already completed. Anybody wants to leave can leave. Okay, how did you enjoy? Yes, we enjoyed our trips very well. So, okay, you can ask any class related question, any topic related question. So, is the class smooth today? Except the first 5-10 minutes. I think all of you felt the class smooth. Internet issue, anything, board clear. Reflection, show your home. Siddharth Reddy, that's a very bad request to show my home. This is not a home, this is just a jail we are living in. So, okay. Modi Somna, thank you. So, you can take a leave, take some rest, and meet me in the next class. Go for the next class, enjoy. Okay, no problem. Very good. Thank you, beta. Hopefully, all of you enjoyed. Thank you. 1 minute, Siddharth. What 1 minute? Okay. Thank you all. Yes. What doubt you have, guys? What doubt you have? Sammi said, bye, sir. Bye. You can leave the meeting. What doubt you have, Siddharth? Who is Siddharth? Which batch? Like before asking doubt, you can ask. Okay, ligands. Yes. Yesterday also someone was asking me about ligands. So ligands is nothing but ligands is a species which can make a coordinate bond with metal. So ligand, metal, ligand. So ligand will have excess electron and metal will have vacant d orbital. Vacant d orbitals. Do you know SPTF? So metal will have maximum vacant d orbitals and this ligand will make coordinate bond. Coordinate bond means complete pushing of electron and making a bond, right? It will donate a lone pair to the metal and it will make bond. So like this it can be Ml2, like one metal 2 ligands, Ml4, one metal 4 ligands, Ml5, one metal 5 ligands. We can have also Ml3. We'll all discuss this in chemical bonding and coordination chemistry. We'll have Ml6 compounds, we'll have Ml8 compounds. So all of this will have. So before asking doubt, you have to mention your batch. Otherwise, I will not recognize you, right? Okay. So ligands we'll study ligands. What is Ml? Array, metal. M for metal, L for ligand. I am just saying you can take any metal, copper, any ligand like ammonia, CO. Okay. Ammonia or carbonyl, you can take any metal, copper plus, iron 2 plus, mercury 2 plus, right? Got it? You can take any metal, any ligand. These are all two very big chapters. So this is in second year coordination chemistry, first year chemical bonding, and you have not entered inorganic chemistry till now, right? You have not entered inorganic chemistry till now. So don't get worried about inorganic chemistry. Sir, please tell properly what ligand means. Ligand means something which will coordinate with metal and make a coordinate bond. We'll understand. This is properly separate chapter. For now, for a beginner, you can understand that ligand is something which has excess electron. It's electron rich and can donate a pair of electron. can donate a pair of electron to any metal's vacant d orbital and make a coordinate bond. And I explained what is coordinate bond in your class. So ligand is an electron rich species which can donate a pair of electron to the metal and make a coordinate bond. And this is a very big separate chapter. So don't worry, you will learn. Don't worry about things. Okay. Sugar patient. Sugar patient कौन है बेटा? Okay. See you all tomorrow. Thank you for joining. I'm ending the live class. Thank you.